For centuries, physics has treated the speed of light as an unbreakable barrier. But what if nature itself has already shown otherwise? In Superluminal Particle Accelerator reactor design, Rosario Elenes Cazares presents a groundbreaking framework that unites observational astronomy, laboratory quantum experiments, and advanced engineering design. Drawing on cometary data revealing natural Bose-Einstein condensates, achieving up to 7% of the speed of light without engines, far surpassing conventional spacecraft, and combining it with laboratory-validated scaling laws. This book introduces the Superluminal Velocity Specification, a practical formula for building reactors that harness quantum coherence to reach and control superluminal speeds. How these reactors differ from classical accelerators, unlike traditional accelerators such as the Large Hadron Collider, which use superconducting materials mainly for efficiency, these systems are fundamentally quantum coherent reactors. Particles are confined within a BEC chamber, and the reactor functions as a unified superconductive circuit. Superconductivity arises from the reactor itself, not from external energy input, transforming the design from a power-driven accelerator into a persistent current quantum system. Cooling is the driver of velocity in these reactors. Cooling, not applied force, drives motion. Electrons near 99.999% of the speed of light achieve this velocity, not through added energy, but by reduction of thermal resistance. As temperature approaches absolute zero, quantum coherence emerges, setting the lower bound of motion and allowing near-light and superluminal speeds to arise from lossless quantum order. Two sides of the same coin here. Space-time warping is quantum coherence. Geometry cannot be observed without collapsing the system, yet it dictates particle motion. In relativity, geometry tells matter how to move. In superconductivity, quantum coherence is the geometry. Superluminal speeds occur when spacetime itself becomes superconductive, fully consistent with Einstein's relativity and Alcubierre's warp drive framework, where warped spacetime allows faster than light motion without violating local physics. Electrons move not by applied force, but because the self-generated geometry guides them. Cooling preserves coherence, enabling the reactor to create the space-time structure needed for motion, linking quantum behavior directly to observed superluminal velocities. Bosons, as the fabric of space-time all forces, electromagnetic, strong, and weak, are mediated by bosons. When bosonic atoms are cooled into a Bose-Einstein condensate, they form a coherent ground state that defines motion. In superconducting circuits, this coherent bosonic field generates the geometric order that guides electrons even with the battery off. Superconductivity emerges because the warped bosonic geometry itself sustains motion, showing that space-time curvature and force mediation are inseparable consequences of bosonic coherence. Because the geometry is fully coherent and self-generated, superluminal motion is naturally permitted without violating relativistic limits. The ultimate warping of spacetime, the most extreme warping, occurs in black holes, where gravity compresses stellar gas to extraordinary densities. As a star collapses, gravity-assisted cooling allows bosonic atoms in the gas to radiate energy while density increases. This combination of cooling and compression enables the bosons to condense into a coherent Bose-Einstein state. The resulting BEC forms the ultimate coherent geometry, creating the profound space-time curvature observed as a black hole. Black holes, therefore, can be understood as nature's ultimate BEC reactors, demonstrating on the largest scale how bosonic coherence shapes motion, forces, and the fabric of space-time.